That's units, because I never really told you what this first unit was about, because you started with the first unit. We're going to talk about roots, square roots and cube roots, okay? Which we've actually done previously, but we're going to add a little bit to it. We're going to talk about exponents again, but we're going to do different types of exponents. You guys are used to the exponents being 0 or 1 or 2 or 3. We are going to now do negative exponents and fraction exponents, okay? And there's actually a relationship between cube roots and square roots and exponents that we'll see later on. Anyway, this first part, yeah, it's essentially a review too. Can somebody tell me what a perfect square is? Or at least give me an example of a perfect square. 16? Why?
Because
right. Okay. So a perfect square is a number that can be written as another number times. And we did talk about these last year. So as Olivia said, 16 is a perfect square because it equals 4 times itself. Okay. 25 is a perfect square. 100 is a perfect square. Is 8 a perfect square? No. Okay. It's going to be some decimal number that never repeats or never ends, but we'll talk about that later. So before I get to square root, if this is what a perfect square is, what do you think a perfect cube is? A number that can be written as another number. What do you think? What do you think? If a perfect square is times itself, perfect cube would be, isn't it one more? Isn't cube mean 3? So times itself times itself. So another number times itself times itself. Can you think of a number that you can get to by taking some other number times itself times itself? 27. Why? 3 times 3 times 3. Perfect. So notice the difference. Okay. We can find the square roots of these and the cube roots of these. So if I said, what's the square root of 36? Oh, come on. Square root of 36. 6, thank you. Because you're asking yourself, what number times itself gives me 36? So square root of a number is what number times itself equals the number under the square root. And what's the square root symbol? It's that check mark with a little bar. That's the square root symbol. So if we said the square root of 36, I'm asking myself what number times itself equals 36? 6. And it just goes to follow a cube root of a number is what number times itself times itself. Equals the number under the square root. Oh, sorry, cube root, pardon me. Number under the cube root. And how do we write cube root? Well, we write a little 3 with what we're used to seeing as the square root sign. So if I said, what's the cube root of 8? So you ask yourself, what number times itself gives me 8? 2. I could keep going. I could find perfect fourths, meaning what number times itself times itself times itself. Okay. Or the fourth root. I could find the fifth root, but I could keep going. Okay. We're only going to stick with square roots and cube roots. And those are types of, like the general name we give to all of those are called radicals. Okay. So when I say the word radical, you're thinking, oh, square roots and cube roots. Okay. So radical, just for our purposes in this course for now, are square roots and cube roots. There's a lot more of them, but we're not going to worry about those. And they always take this form. There's a little number outside the check mark with the bar, and then there's some number inside. Right? So n is called, you don't have to, you just should be familiar with this word. It's called the index. So if n is 2, square root. If n is 3, cube root. This is just called the radical sign. And whatever's underneath that radical sign is called the radicand. You don't have to memorize definitions or anything. You should just be familiar. When I say the word index, you should be familiar with what I'm talking about. Before you turn the page, you're used to seeing square root like this. Remember this. It's also the same as this. You might see that sometimes, a little 2. Okay? I mean, it's like when we write X, we assume there's a 1 in front of it. We just never write it. It's kind of like that. If there's no number in front, you always assume that number's 2 and you're taking square root. Okay, let's do just a little bit of practice. So, how do you do it mentally? How do you do it using a calculator? What's the square root of 81? 9. That's pretty easy. You guys are used to that. What's the cube root of 64? This is where you got to kind of estimate. Like, obviously it's got to be a number smaller than 64. But it's got to be pretty small, right? If that number times itself gives me 64. What do you think? 4? What's 4 times 4? What's 16 times 4? It's this. So 4 is correct. Now, see all of you with your calculators. You should have a scientific calculator you use and that you're comfortable with, okay? I don't believe it's in the food bag. Just saying. So, it depends on your calculator, but probably somewhere on your calculator, you should have that button. Or maybe it says this. Okay. Now, on some calculators, you punch in the number first, then square root. On other calculators, like the one that I told you guys to get last year, if you were in my class, you punch the square root button first, and then the number you want to take the square root of. Did anybody get this?
It's 36.
36. You should know how to do it on a calculator. You should be familiar with square rooting. Okay? You should also be familiar with cube rooting. Okay? Now, cube rooting, it depends on the calculator. Like some calculators may have a button that looks like this, or it may be part of the shift or the second function. Okay? If you've got a calculator like I think you two do, you would go okay, you got a cube root right on this. You're good. Yeah, some calculators have a cube root right on it. Yours, I think you're going to have to, you know how to do it. Oh, it's, so it's there on the square root. You okay?
Yeah.
Everybody okay? Okay.
Yeah.
And then watch. Okay. Should work out to 12. Okay. Again, you got to know how, because you could be asked questions where you're going to have to use a calculator to find the answer that we'll see momentarily. Okay, so you got to make sure. And borrowing a calculator probably doesn't help very much. If you don't know how to use the cube root button, get your own calculator and use it. Okay. Some other questions. Perfect squares between 10 and 50. What do you think the smallest perfect square is over 10? Is 10 a perfect square?
No.
11? 12? No. What do you think the first one is? Sorry? 13, no. 16. Now, how can you get these perfect squares? Just think, 16 is 4 times 4. So the next one must be 5 times 5.
25.
And the next one must be 6 times 6. And the next one must be 7 times 7. And now I'm above 50. So I stop. How about perfect cubes between 0 and 50? What's the first number? What's the lowest number between 0 and 50? The lowest whole?
4. 3.
No, just not the perfect cube. Just tell me the lowest number. 1. Is 1 a perfect cube? Can you do something times itself and get an answer of 1? You sure? 1. 1 times 1 times 1. So 1 is the first perfect cube. What's the next one? Well, this is 1 times 1 times 1. The next one must be 2 times 2 times 2. 8. And the one after that must be 3 times 3 times 3.
27.
27. And the next one must be 4 times 4 times 4. But we already saw that was 64. That's too big. So we're done. Okay. These ones, use a calculator or do it in your head. This one might be hard to do it in your head. So I would say use a calculator. Anybody got it? 25. This one, definitely a calculator. 17. This one could be done in your head. Remember, the square root of a fraction, it's the same as the square root of 9 over the square root of 64. What is the square root of 9? 3 over the square root of 64. 8. That's how you would show your answer. Don't go to decimal. Don't go to decimal with these. Here is the same kind of thing, except instead of square root, it's the cube root of 27 over the cube root of 8.
3 over 2.
3 over 2. So you could see questions like this where it says answer as a fraction. I won't accept decimal, because then you're just using your calculator and maybe you don't really understand what you're doing. You just know how to use a calculator. Okay. All right, finally, where can we use these things? Here's a couple of word problems. Whoops, sorry. Not there yet. Oh, this is where you got to think. I'm going to make you think. This is not even grade 10. This is like grade 11. It's the square root of x to the 6th. Remember what square root means. What times itself gives the x to the 6th. When you multiply powers, what do we do with the exponents?
You multiply.
No, you add it, right? So I'm trying to figure out what exponent plus itself gives me 6.
3.
3. So it's x to the third. Because x to the third times x to the third is equal to x to the 3 plus 3, which is x to the 6th. That's why it works. Actually, there's a really easy way to find the square root of exponents. Just cut the exponent in half. What's the square root of x to the 10th?
5.
X to the 5th. X to the,
Okay.
right? What's the square root of x to the 100th? X to the, cut it in half, 50th. Right? What about cube root? Now we got to change our thinking again. What exponent goes in here?
4.
Excellent. 4. So how do you square root an exponent? Cut it in half or divide 2. How do you cube root an exponent? Divide it by 3. Okay, now let's look at a couple of problems. Square has an area of 196 square centimeters. What is the perimeter? What do I need to know before I find the perimeter? Like, what do I need to know in order to find the perimeter? How do you find the perimeter of any square? Perimeter. Add up all the sides, right? What's so special about the sides of a square? They're all the same. So, don't I need to find the side? How do I find the side of a square if I know the area? Isn't this and this going to be the same? So what times itself is 196? What's another way to say this? You're finding the square root of 196. And that should give you 14 centimeters. That's the side length. Now that I know that this is 14, and I know that all of them are 14, I can find the perimeter. Either add the 4 14s together, or just do 14 times 4. And I get a perimeter of 56, and because it's length, just centimeters. Just centimeters, okay? I know. I've requested to pump up the air conditioning. It's not great. And the final one, a cube. How do you find the volume of a cube? What's so special about a cube? What's so special about the sides of a cube? They're all the same. Okay? And the volume is the space inside. So really what I'm doing this is interesting. I'm trying to find out what times itself gives me 4,913. What's an easy way to do that on your calculator? Cube root. Let's
17.
17. And that's inches.
So this is 17, this is 17, this is 17.
Now, remember last year we did talk about how to find the surface area of a cube.
And I gave you the formula. You take the length of it, square it, and times 6. So the surface area is going to be 6 times 17 squared.
What do I do first, the square or the multiplication? The squared. What do you get when you do 17 squared times 6?
289.
289, and because we're surface area, it's
Inches squared.
Oh, wait.
No, that wasn't multiplied by 6.
Yeah.
17 squared and then times 6.
1,734.
1,000. 1,734 is better. There we go. Okay. So you can see this is where we can use square roots and cube roots when we're dealing with area and volume of shapes. Okay. Okay.